So today does begin Unit 5, which is our statistics unit. And this unit will take us up to the end of the semester. Our Unit 5 test will be on, just making sure I have the right date, it's May 14th. That's on a Monday. That leaves May 16th as our last day of class. I do the test on the second to the last day just because it gives us time in case people need extra time to finish them up. Make sure they get to me on time so I can have them graded. And hopefully on May 16th, I can have them graded and back to you so that we can work on corrections on that day and some extra credit. So that's our schedule here for the rest of the semester. We're almost there, 2 more weeks, less than 2 more weeks. Only 4 more lectures and then a couple of days of activities for you guys. So let's talk about our statistics. We're going to start out, there's a lot of vocabulary that we have to deal with in order to understand statistics. Statistics really is almost like a language of its own. The biggest thing, most important concept in statistics is a population. And a population is nothing more than the group. That could be a group of people, a group of items, a group of concepts, whatever, that we desire to learn about. Now, the idea of a population seems pretty simple, but it's often kind of tricky to define a population. For example, let's say that we want to learn about the next citywide election, school board election. So in the school board election, we want to know who is going to win coming up in a couple of months. Well, your first instinct is to think we want to learn about the candidates for the board. That's not really what we want to learn about. Yeah, we'd like to know if who's going to win and who's going to lose, but the group we're really looking at is voters. Now it gets even trickier from there, though. We're not looking at all registered voters in the district. What we're really looking at is voters who will vote in the election. If they're not going to vote in the election, they're not going to affect the outcome, so it's not going to give us any more information. Now, in something that describes that population, now, anytime we're doing a statistical study, there is something called a random variable. We are asking a question. And once you've defined the population, we can formulate that question a little bit better. Because, I mean, the question we think we're trying to answer is who's going to win. Well, the question we're really asking is who are you going to vote for in that election? So the answer to that question is our random variable. We'll talk a little bit more about that random variable later on. But for right now, we want to talk about something called a parameter. A parameter describes the random variable in relation to the population. So after the election, we could very easily get a population parameter. We might say that after the election, we might say that 57% voted for candidate A. So we would know that parameter. Most of the time, we do not look at a full population. And there are a lot of reasons for that. I mean, actually, once the election occurred, there's really no reason to look into this anymore. We would be looking at before the election, trying to predict the result. And trying to predict the result, trying to get a hold of every voter would be pretty tedious. So what we do is we select something called a sample. And a sample is nothing more than a smaller group selected from the population. So the question is, why do we select a sample? Well, there's a lot of reasons why. The first couple are pretty obvious, and they're usually linked together: time and money. Surveying every potential voter in the district would take a lot of time, and it would get to be expensive. The other ones are not quite as obvious, but just as important. If I wanted to try to gather information from the whole population, I have to be able to define who that population is. Now, in many cases like this one, they don't even know if they're in that population or not. If it's 2 months away from the election, many people, or not many, but some people can't tell you for sure whether they're going to be able to vote or not. They may have to work late, or they get a flat tire, or something comes up where they can't vote. Or at the last minute, something happens that gets them excited and they weren't planning to vote, but they vote anyway. Another one is time sensitivity. Time sensitivity is a little bit trickier to understand, but again, just as important. Let's say I'm going to call up and ask all these voters who they plan to vote for, and it's going to take 4 days. So I call a bunch of people on a Monday, Tuesday. Now remember, the question I'm asking them is not who are you going to vote for in this election, because they really can't answer that. What I'm probably going to ask is, if the election were held today, who would you vote for? Well, let's say on Tuesday night, one of the candidates is arrested. Well, on Wednesday, I continue my calling. There's an issue here. Those phone calls, those people I interview on Wednesday are not interviewed under the same conditions as the one I talked to on Monday and Tuesday. In fact, many of these people from Monday and Tuesday would probably change who they were going to vote for after that current event. So technically, a good survey is done in an instant. It's what is called a snapshot. In a perfect world, which we know is impossible, we would pick who we were going to call, and we would call all of them at the same instant in time and gather information from all of them at the same moment. So not even a few seconds in between could make a difference. And then the last one we're going to, there are several other smaller reasons, but the last one we're going to talk about is altering the population. This takes a couple of forms. One, in surveys, often if you're asked a question often enough, it can change your answer to that question. You know, you get asked the question, are you going to go to the beach with us this weekend? I don't know. Are you going to go to the beach with us this weekend? I don't know. Well, after about the 12th time you're asked, I said, you know what? No, I'm not going. Leave me alone. Getting interviewed or surveyed often enough could affect what you're actually going to do, or it could put something you hadn't heard about before. Maybe you hadn't even thought about voting in this election. Getting called and surveyed, hey, you know what? I think I will vote. So by using a small enough sample, you ensure that you don't significantly change the whole population. Now, the next part here, the other side of that altering the population is not dealing with surveys, it deals with industrial testing, destructive testing. let's say you're producing parts and those parts have to have a certain strength to them. One of the ways of testing that part is to put it in a machine, put it under a certain amount of force until it breaks, measure the amount of force it held before it broke, and see if it was strong enough. Well, if you tested every part, they would all be broken and there'd be nothing left to use or sell. So you're going to take a sample where you test enough of them, and if all of those pass, you're relatively certain the rest of them are good as well. So like I said, there are other smaller, less important reasons. Those are the 5 big ones. So from that sample, we gather statistics. Statistics are describe the sample in terms of that random variable. They describe the random variable as it relates to the sample. So maybe we surveyed 300 people and we found that 60% plan to vote for candidate A. That's a statistic because we're describing the sample that we took. Whereas before we said 57% of them did vote for candidate A. That was the whole population. That's a parameter. A survey is used when gathering information from a sample. Then the word that you're probably hearing starting to bounce around a little bit now because it's going to come up in 2020 is a census. A census is an attempt to gather information from a whole population. Every 10 years, the US government sends people out to do the census. They're trying to gather information from the whole population. Now, it is a little bit of a misnomer because the true census has never happened. The true census would have to reach every living person in the United States. And it's never happened. There's always at least somebody that refuses to answer or they just can't get in touch with or whatever. So it's never complete, but it is an attempt. So now, that sample, in order to be usable, in order for all this to work, has to be what's called a representative sample. What does that mean? Very simply put, briefly put, that the sample statistics are approximately, really as close as possible to the population parameter. So we took that sample, we found 60% plan to vote for candidate A. In the re-election, 57% of the population. That was pretty close. That was probably a decent sample. So the question is, how do we choose a representative sample? There are a couple of ways of doing this. Concerns that we have, things that we have to address. First is sample size. I'm not going to talk a lot about sample size because there's a lot of different ideas on how to justify a sample size. I'll say this, I can't just walk out in the hallway, interview the next 2 people that I see, ask them who they're gonna vote for. One of them says candidate B, the other one says candidate A. I can't go then and say, hey, it's an even split between candidates as to who's voting, who they're voting for. That would not be a big enough sample size. Other statistics has a couple of different schools of thought. And so for many of these, there's 2 or 3 different interpretations that can be used. One of the big ones for sample size is that sample size has to be less than it should be more than 5% and less than 10% of the population. More than 5% is put out there so that it's big enough to be, good chance we got people from all groups. Less than 10% is to avoid that thing we said earlier about altering the population, by pestering them when it might change their mind. For this class, we're not going to really do a whole lot about adequate sample size. Randomly selected is huge. We're going to talk about types of samples in just a moment. So types of sampling or sampling strategies. And the last thing we have to do is less than how we select our sample and more about how we approach it. It's unbiased methods. And this is really where the psychological side comes into statistics. There's been a lot of published opinions out there about, Mark Twain once was quoted as saying there are lies, there are damn lies, and then there are statistics. And there's a lot of truth behind that. There's a lot of money that's put into psychological studies as to how to influence the outcome of statistical studies. One of those is just in wording, like if it is a worded survey. Let's say your school district wanted to do some remodeling to improve the environment of the classrooms, to make it easier for you to learn, maybe update some technology, update some heating systems to make the rooms more comfortable, stuff like that. Well, if they worded their question, if they obviously that would require a tax levy, which would have to go on a referendum. So if they wanted to survey people to see if that was going to have a chance of passing, we might put out there, a question out there of, would you be in favor of paying more in property taxes in order to support a better learning environment in our K-12 schools? Well, what happens there is the person listening to that question hears, would you be willing to pay more in property taxes? And many times at that point, they have already said, no, I would not pay any more in property taxes. And they don't even hear the rest of the question. Now, the other side is you could word that question like this, where if it meant creating a better learning environment for our K-12 schools, would you be willing to pay a little bit more each year in property taxes? Just by changing that order around, people start off, the first thing they hear is better learning environment for students. They're already in favor of it, so that by the time it gets around to saying more in property taxes, they're more likely to say, yeah, okay, I'll give a little bit. So just simple order of wording and stuff like that, adjectives used and things. Color of print, if it's a written survey. There's been a lot of studies done on that different colors of the paper and of the print itself encourage people to answer favorably or unfavorably on questions. Let's get back to this sampling, selecting samples. So the big word we threw out there was random. Random means every element, an element is a person or an item or whatever in the population has equal chance of being selected. So every person or every item in the population has an equal chance of being part of that sample. There's something a little bit more powerful than random, and it is called simple random. It's called simple random because there's no system or process behind it, and it's a little bit tricky to define. Let's say our sample size that we are going to use is labeled with the letter little n. So sample size little n. Simple random means not only random, not only does every element in the population have an equal chance of being selected, but every possible sample of size n has equal chance of being selected. So to illustrate these, the next names of different types of samples, we're going to look at a population of 100 items. So 1 up through 100. And we need a sample of 10 items. Our first type of sample we're going to talk about is a convenience sample. A convenience sample is quite simply you take readily available information. In other words, you take it what comes easy for you. You might, on your walk home from school tonight, knock on the door of every house you walk past and ask them who they plan on voting for in the election. That's a convenience sample because those are houses you were going to walk by anyway. All you have to do is stop and knock on the door. Or you could, the next 10 people you see walking down the street, you're going to ask them who they're going to vote for. That's a convenience sample. A convenience sample is not random because people that are outside of whatever convenience you are using have no chance of being selected. People that are not on your route home, they're not going to get their door knocked on and surveyed. So a convenience sample doesn't work as random or simple random. Next, I want to talk about something called stratified sample. In a stratified sample, let's go back to that school board election idea again. In a stratified sample, let's say we have people who have children in school and people with no children in school. Oops, I spelled that wrong. And let's say that we have, in the district, 60 people have children in school and 40 don't. Again, that population of 100. So we would select 6 out of the ones that have children in school, and we'd select 4 out of the ones that don't have children in school. We're still getting our sample size of 10 out of our population of 100. Does everybody have an equal chance of being selected? Well, yeah, we chose 1 out of 10 of the people that have children in school. We also chose 1 out of 10 for the people that don't have children in school. So this is random. However, it is not simple random. Why not? Because it is possible to have a sample where all 10 have children in school. That sample could not possibly be selected. Now, you might argue in this case that it's better to do this stratified sample so you make sure you get some families that have kids in school and some families that don't. And I wouldn't argue with you on that, but it is not a simple random sample. For some cases, though, depending on what statistical processes you're going to do, you don't require a simple random sample. So if you're just gathering information, this might be the best way to do it for that case. Something called a systematic sample. A systematic sample, we have that population of 100 people, and we want a sample size of 10, so that means we need 1/10 of the population sample. So we could randomly select a starting point. One through 10. And let's say, for example, the number we selected was 4. So what that means is out of those 100 items, if we had them numbered 1 through 100, we would take 4, 14, 24, 34, 44, on up to 84 and 94. We have a sample size of 10 out of our population of 100. Every item has an equal chance of being selected because there's a 1/10 chance of selecting any of these numbers. So every item in that population has a 1/10 chance of being selected. So this is random. However, once again, it is not simple random because it is not possible to have a sample that includes both item number 3 and item number 8 in the same sample. Because once we selected that starting point, every 10th item is used. So it's not simply random. Now again, there are cases where a systematic sample may be better than a simple random sample. And manufacturing would be one example. If we want to test parts, I would rather test parts coming off that line 1 every 10 minutes than having to test, randomly selected. You might get all your parts all at once and then not test any for 2 hours. I'd rather have them evenly spaced so I know that the quality is staying up, staying where it should be. Next, we have a cluster sample. And what we do in a cluster sample, similar to a stratified sample, in a stratified sample, we broke the population into groups. But in the stratified sample, we selected a certain percentage then from each group. In a cluster sample, we select whole groups. Well, why on earth would we do that? Well, let's say we are going to go door to door and ask about these, the school board. If we have city blocks that we're going to cover, if I do a simple random sample, I might have somebody here to survey, somebody here and here, possibly here and here and here and here. I could end up with some really weird traveling all over the city surveying people that have been selected. Well, that's kind of inconvenient to have to walk from one to the next and whatever. So what I could do is I could just select, hey, I am going to do this whole block, this whole block, this whole block, and this whole block. And I'm going to survey everybody on each of those blocks. So I'll still get my sample of 10, but I won't have to bounce all the way around the city. There are arguments as to whether a cluster sample is even truly random, as long as the clusters were the same size. For example, as long as there were, let's say, exactly 2 people living on each block, then it is truly random. However, In no world is it simply random. Because it is not possible to have a sample that includes this person on this block, but not that person. If they're on the block, they are included in the sample. So let's get down to it. Nothing has been simple random so far. So what does it mean to be simply random? How would we create a simple random sample? Well, the old equivalent would be to just put names or numbers in a hat and draw out how many ever we need. In this case, we draw out 10. So we'd put numbers 1 through 100 in a hat, we draw out 10 of them, that's our sample. In that case, every item still has an equal chance, 1 in 10, of being in the sample, and every possible sample has an equal chance of being selected. It is possible, not very likely, but it is possible that I could draw out the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That could be my sample. In most of my other methods, that wouldn't be possible. Some advanced statistical processes require a simple random sample. We're not going to get into any of those processes, but it's good to know where they come from. So let's go back to that question being asked. We said that the random variable was simply the answer that each element in a survey, people, other tests might be parts or whatever, would give to that question. So we have a couple of different types of answers, types of random variables we could have. We have categorical, or what's sometimes called qualitative. Categorical means the answer to that question puts you in a category. One would be, what's your favorite color? Well, you answer red. Well, that puts you in the category of people that chose red as your favorite color. What month is your birthday? You say July. Well, that puts you in the category of people who were born in July. We have numerical or quantitative. Quite bluntly, your answer is a number. How many classes are you taking? How many pets do you have? How many siblings do you have? How many cars do you own? Those are all questions that would be answered with a number. How old are you? What's your height? How long did it take you to do this test? All quantitative or numerical. Well, within each of these, there are subcategories. In the categorical, there's something called nominal. Nominal literally means just by name. That might be color would be nominal. Any yes or no question is categorical or qualitative. That would be nominal. Your answer is just a name only. There is also called ordinal. Ordinal have a natural order. So what's your grade in this class? Well, if we use letter grade, your A, B, C, D, E, or A, B, C, D, or F, there is an order to that. A B is better than a C. So even though it's categorical, there is a logical order. Another example might be order a soda at a restaurant. Small, medium, or large. Obviously, large is bigger than small. Small is smaller than medium, and so on. There is an order that you can put those in, even though they are categorical. On the numerical quantitative side, there's actually a couple of different divisions we have to see. We have discrete, and we have continuous. My battery's going bad in my pen. There we go. The easiest definition I have found here to describe as discrete are things that can be counted. Continuous are things that are measured. A measurement requires some sort of device. So discrete might be how many classes do you have? How many siblings do you have? How many cars are owned by your household? That is discrete. Those are things that are counted. Continuous, what's your height? What's your weight? How long did it take you to complete this last exam? Those are continuous. Now, some that are kind of a gray area. One that always comes up is money. Is money discrete or continuous? Well, money, if you assume that you're going to be rounding to the nearest penny, it can be counted. Money is discrete. It is countable. You can count your pennies. Age. This all depends on how you're going to count age. If you're just saying years, you say, I am 17, that would be counted. But if you want to keep track of your age as far as, 17 years, 3 months, 5 minutes, 2.783 seconds, whatever, could be continuous. For the most part, time is continuous. Because time is only limited by where you round it off. You could take it out, you could measure out to a millionth of a second if you wanted to, if you had a precise enough device. Age can be limited. I mean, like I said, you can measure it out to that hundredth of a second or millionth of a second, but usually age is counted in years. So even though it is a time, we generally consider it to be discrete. But again, you have to be careful as to how it's defined. Continuous being measured doesn't mean that we can't count them, but the limit is in the measuring device. For money, yeah, you can have a millionth of a penny, but the limit going to a penny or the hundredth of a dollar is a convention. That's just the standard way to deal with money. It's not measured by the measuring, or limited by the measuring device. It's limited by another outside standard. Time, there's no outside standard except for age. In the most part, time does not have an outside standard that limits where you're going to round to. It's your device, your clock that you have, your stopwatch, or whatever you're using that limits it. Measuring height, you're limited to by the smallest division on the ruler you're using to measure your height. So it's the measuring device that causes that limit, not some other outside standard. And there are always going to be some gray areas in between discrete and continuous. Now within those, there are levels of measurement. There is also ordinal. Ordinal, the biggest thing about ordinal is that there is no, from one to the next, there's no difference. The difference does not matter. Thanks. So the difference is not significant. This might be if you're looking at rankings on standardized a rubric for something. Scoring a 32 compared to scoring a 36 might not be the same difference as the difference between a 36 and a 40. You know, a 40 is still better than a 36, and a 36 is better than a 32, but that 4-point difference may not have the same meaning. There is interval. In interval measurement, the difference is significant. So back to that previous example, you have a 32, a 36, and a 40. Then for interval measurement, you could say that this 4-point difference is the same as this 4-point difference. So this person was as much better than 36 as the 36 was the 32. So it is implying that intervals are equal, they're the same. Finally, there's ratio measurement. The biggest thing with ratio measurement is there's a natural zero. Like height is a good one. You might say somebody who is 40 inches tall compared to someone who is 80 inches tall. You'd say the 80-inch person is twice as tall. But it's not necessarily true. There's nobody out there who's 0 inches tall. There is no natural 0 point. On many of these rankings, there's no natural 0 point. Money, however, I've had several points in my life where I had $0. There is a naturally occurring 0 point. So somebody with $10 does have twice as much money as somebody with $5. Okay, that is all we wanted to go through for vocabulary for today. The good news is, for your weekend, there is no homework. So we'll pick up next week. We have 3 hours of lecture next week on statistics. That'll be what we have to prep us for our test on the 14th. You guys have any questions? Okay, well, you guys have a great day and have a great weekend.